Okay, I wanted to finish up the notes. We didn't get to quite finish today in class over continuity. So let's take a look at example number 5. It says to, looking at the graph, state the x positions of discontinuity and to identify which are holes. Well, we can do that just by looking at the graph. We see there's a hole here. X equals -4. And what else do we see as a discontinuity? And at x equals 3, there's another hole right here, so we could just state those. Take care of the first part of this problem. At x equals -4 and x equals 3, we see that there's a discontinuity. And now they want us to answer the questions about the limits. And more importantly, this one is a hole, and this one is a jump discontinuity. See the difference on this one? At 3, there's actually just a jump from this -1 down here to -4, whatever that is. So anyway, let's take a look at the limit problems. Here they're asking us to find the limit of +4 as x is coming in from the left side. So from the left side at -4, which is where we have this hole, you can see the limit approaches the line y equals 1. There we go. And from the right, it's approaching also +1. So in general, the limit, since the left and the right hand side equal each other, the limit is 1. Okay, so the next part says the limit as we approach 3 from the left. As we approach 3 from the left, we are sliding this way, and it looks like we approach -1. And as we approach 3 from the right, we're coming from this direction, and we approach -1, 2, 3. So this is just identifying graphically where the discontinuity points are and what the limits are. So example 6 is pretty important one we didn't get to today. It says determine the value of b such that the function is continuous everywhere. So we could start off with a graph of this piecewise function. And if we do, well, we see that the dividing line is when x equals 3. Because see how the break here is when x is less than or equal to 3, we follow this rule bx squared, and if it's greater than 3, we follow the horizontal line y equals 2. So let's go ahead and mark off our graph here. And so I want to consider this section right here. This is my dividing line, right? So let's follow the rule when it's greater than 3. So when it's greater than 3, it's just equal to a horizontal line of 2. Okay, and it'll just continue on there forever. So what are they asking us? They're asking us to figure out what b is so that it's continuous everywhere. So let me just sketch something that I'll eventually erase. But so if I had bx squared and it ended up not connecting at 2, so for instance, if it did something like this, when it got to 2, it was way up here at, say, maybe +5 or 6, then this would not be continuous. So we want the blue quadratic and the black linear line to meet up here. Well, where do they meet up? They meet up at 2, right? So if we set these two equal to each other, we should be set. So what is the function value here? It's equal to 3 squared, right? So that gives me at 9b, and we need it to equal R2, right? So if we divide by 9, we get that b is equal to 2/9. So if we put 2/9 in front of that x squared term, we get that this function is 2/9 x squared when x is less than or equal to 3. So it would look something like this. Let's just double check this on our calculator. So into the first function we're going to put 2/9 of x squared, and into the second equation we're going to put the value 2, and we want to trace our calculator and see if this intersection point is in fact equal at 3. So we're basically looking to see if the graph does this. Alright? Easiest way to do that would just probably be to hit the trace button and type in 3, and you can see that it's equal to 2 there when I'm on the equation 2/9 x squared. Double check it with the table setting, and you can see that the function in y1, which is our 2/9 x squared, is equal to 2, and then in y2 we have just the equation y equals 2. Since they're both equal to 2 there, we have completed our mission. So anyway, hope that helped, and I'll make a couple videos of some of the homework, and we'll see you in class tomorrow.